Alrighty, Hacksters! Today we are here with Davill, who is a person who's created so many beautiful things. Not only beautiful PCBs, beautiful LED art, and also a bunch of interesting FPGA boards that we're going to look at in just a moment here. Good morning, Greg. What's up?
Morning, Alex.
So how would you describe yourself? Are you a maker, a tinker, an engineer, a designer?
Yeah, I'd probably say I'm an engineer first and foremost, and then kind of a bit of a maker on the side. Um, I don't really know what the technical difference is, but usually my projects, I'm looking at a problem and working out how to solve the problem with like electronics or software, firmware. Whereas I guess on the maker side, most people, I guess, is a bit more creative. You're just creating something, for the fun of it.
Solid. Well, then maybe let's jump in and take a look at some of the projects that you've created to solve some problems. First off, you just mentioned to me that actually for your work, you work at Fireflight doing this real-time fire mapping hardware. Could you tell us a little bit about that just right off the bat? It's so
Yeah,
cool.
sure. So we basically have created a thermal camera system, uh, which here's a prototype that I've just got on my bench. Unfortunately, all our other cameras are actually currently deployed. Um, but basically, this is a camera platform that I've helped design, and this one's clearly a prototype. And it's basically thermal cameras that are then with some hardware magic inside this beautiful enclosure here, outputted to a computer, and then combined with just a small MEMS IMU, we basically can capture thermal data from at the bottom of a manned aircraft and project that to the ground in real time and create kind of like a Google Maps overlay of the fire ground as it's currently burning.
Wow, that seems incredibly relevant right now and incredibly useful for
Yeah,
people.
definitely.
You said that it's obviously a prototype, but to me it looks really beautiful and polished. Can you tell us what the difference
Uh,
would be, you know?
so I just mean the bottom here is a 3D printed nylon part, and there's visible screws and stuff. Probably can't really tell, but there's some bits that I've dremeled out on the inside to make everything fit.
Ah.
The top here is actually what we use on production models, but it's like the base here is quite different.
So what is your
Um,
role in this? What are you doing with this hardware here?
well, at Fireflight, I'm the I guess the lead hardware engineer. So I'm responsible for um, I guess making sure that we have hardware to fit our requirements. Um, and so I've designed this and had prototypes manufactured, and then worked on the firmware and software to kind of get it up and running. Interestingly, this you probably can't really tell from the outside, but this actually was the reason that we created the original Butterstick board.
Oh.
So this is the original uh, Butterstick FPGA board, which I think is probably on the list to talk about here in a minute. But so this is version 0.2. And basically, we use this board inside the camera. It just kind of sits in there. And then there's just kind of like an add-on board on top that that does all the application-specific tasks.
So you're
Like
doing like image
plugging into the cameras.
processing?
So there's no image processing on this. It basically takes in data from the thermal cameras and data from the IMU, make sure it's all paired nicely, and then sends it to a computer over Ethernet. And then on the computer, we can do more advanced processing.
That's really cool. What kind of other expansions are you envisioning that might exist for this? Because I see you've got those those very high density connectors on the top there.
Yeah. So here I could. This is the new version.
Ooh,
Mm. So more or less, it's like similar uh, similar guts. They're both an ECP5 FPGA, and then the high-speed connectors here are actually a format called Syzygy, which was developed by a company called Opal Kelly, which are based out in Oregon. So this is their FPGA board. And so they developed this kind of expansion format called Syzygy, which uses these Samtec connectors that I think can carry about 32 high speed signals.
hmm,
And then they've got a few different breakout boards. And then I've been working on a couple. So uh, this one here is 4 gigabit Ethernet. We've got one here that does HDMI input and output. Um, I think,
cool. I love the different colors. Do you always change
yeah.
colors when you change versions of something, or?
I usually just pick kind of just pick a color. I mean, these ones are, OSHWA purple,
Yeah.
um, and then red. This one is a breakout for a FLIR boson thermal camera, and I picked a thicker circuit board. I've never done anything with circuit boards thicker than 1.6 millimeters before, and so this is 2. And it's more just to get a feel for like different different technologies and different, like the same with the colors. It's like if you only stick to green boards, you don't really know if a project would be really suited for a different color or not. So for prototypes, I definitely try to jump around to different colors. And you can see on this one, I've done a fancy silkscreen
Yeah.
um, image. I think that's a diffusion reaction or something like that. It's like a process for making like funny patterns.
Cool.
Mm.
And what did you use? Do you use processing to create that? And do you put it into Eagle or KiCad or?
I think that one was possibly a stock image that I got from uh, one of the stock image sites I've got an account with. And then I've just pulled it into uh, KiCad. I do all of my circuit board designs are done in KiCad.
Excellent. Me too. It's good open source software. You've got some
Yeah,
really
and I mean
cool.
it does everything I need it to do. So and it's more than capable enough. So anything from most of my boards here end up on 4 layers just because I'm working with higher speed signals. Um, but the butter stick here, it's got 2 DDR3 chips right next to the FPGA. So to route all this, that was on an 8 layer board.
Ooh,
And KiCad doesn't have a problem with that. You can go up to as many layers as you want, really.
it's just about finding a fab house that will do it properly.
Yeah, it's not crying when you see the invoice come in. It's
Oh yeah, imagine cost must be a big factor in your fab house costs because you're working with such intense designs. What else do you consider when you're looking for a fabrication house?
probably, I guess, like reliability is probably one of the biggest keys, and consistency, because I like it. It takes a significant time to switch between um, different fabrication companies. You've kind of got to evaluate, you know, a new company and work out if the boards they're producing are going to be up to the standard you need, and everything like that. So personally, I do probably prefer consistency in results over anything else. I mean, it's no good ordering prototypes getting them, building them, finding that they're all working. But then when you get to building a production board, the quality's just changed dramatically.
That makes total
That's
sense. Even if it's lower quality, you can probably like work with it if you know the quirks. But if it changes
yeah.
on you, then
If it was kind of low quality in the prototypes and like it doesn't change, then you could probably make it work. But if you're already pushing up against kind of tight design tolerances and it's marginal if the prototype's going to work, and then in production, you get a pretty low yield because of you're let down by the circuit boards.
mm.
It's no fun for anybody.
So you've got a couple different versions of the butter stick there you mentioned, and I noticed that on the newer one you have what looks like maybe a USB-C port where there wasn't one before, and you also have the micro SD card slot in a different spot. What kind of upgrades did you do, and why did you choose to do this?
Yeah, so there they are side by side. So the main updates between the two are the memory here. On the first board, on the V0.2, we've got HyperRAM memory. So it's 32 megabytes, I believe. I think each part is 8 or 16 megabytes on this board. So it's quite low size, but it's quite a simple interface. So if you've ever worked with SPI devices, so like serial peripheral interface, you kind of got a data, a clock, and a chip select, data in and out of the chip.
Mm-hmm.
And you can extend that to quad SPI, which uses 4 data lines and a clock chip select. These HyperRAM chips kind of move that one step forward and use what I think some other companies called OctoSPI.
Whoa.
But it's basically an 8-bit data bus combined with a clock. So we've kind of come full circle with that because a lot of old interfaces used to be parallel interfaces. And then we switched to serial processing. So you have less pins, but there's more data. And we've kind of gone back to using more pins, but also parallel data. So kind of come full circle. But these chips are nice because they're reasonably high density for the size of the chip. Quite a simple interface, but they're kind of a little bit on the expensive side as well. I think for 8 megabytes, you're looking at I don't know, anywhere from $4 to $8, depending on the quantities you want to buy. Which is more expensive than DDR3, which is what we've used on the new version. And so the DDR3 lets us, with 2 chips, we can fit up to 1 gigabyte of memory on this board.
Oh.
So it's a bit of a jump between 16 or 32 megabytes to 1 gigabyte. But luckily, the ECP5 gives us the capability to talk to DDR3 memory. So we've kind of just used the opportunity there to put that on this board. Additionally, as you said, we moved some of the parts around in the bottom, but they both have a micro SD card.
You got a couple of buttons on the new one?
Yeah, the first one didn't have any buttons, and so we put 2 here. Just makes it a bit more useful to do things like entering the bootloader, or if you're running some code on here, just a couple of buttons on the main board kind of does help. You'll notice that on most FPGA development boards do have a bit of included I/O. And then additionally, both of these boards, the main point of them was to have the syzygy connectors, so the high-speed peripheral, add-on connectors, as well as gigabit Ethernet. So we've got an Ethernet port on both of these, and then a gigabit Ethernet PHY on board. And then on the the new version, we've also added USB 2 high speed. So this
Mm.
little chip here is a high speed USB PHY, and then I've put USB C connector on there too. So you can power the whole board off USB C or plug in some external power on this little jumper here.
Solid. You've also, I'm going to show this because your photos are so sublime. You've got this little extra butter graphic on there as well, which I think is an excellent addition.
Yeah, yeah.
You've got so many beautiful people. Really have to check out your Instagram because we're going to be focusing here mostly on the technical stuff, but just look at these gorgeous close-up photos of, for example, the solder mask on, or the solder paste on there, and then the uh castellated edges on this guy and stuff, and then this, like, what, incredible. Bodging an entire, what is it, 32 pins chip. That's ridiculous.
Yeah, and so that actually, that wasn't even my chip. It was a friend of mine that got the footprint wrong on his circuit board,
Oh.
and so I was like, oh, we could probably fit that chip on there. So he sent me the circuit board and the chip, and I soldered this up for him, and then sent it back. But the turnaround time on circuit boards these days is so low that I think he already had the new circuit board by the time I'd finished this. So.
Oh, wow.
But
That's
no, it's a fun exercise, and you
mm,
kind of get into a bit of a zen with soldering under the microscope, and
mm-hmm.
you can. So I find it a bit of a relaxing task.
You even have those
Some people
wires like
might look at
perfectly
this and
length matched, so they go, ah, I could see that.
yeah, so,
Yeah,
some people might look at this and like start pulling their hair out, but you know,
it's beautiful. Um, so is this a photo that you have a microscope hooked up to your computer and you're like taking screenshots, or do you have a separate camera that you use for these incredible macro shots? Or someone else in the company was curious about it, so.
no. So this is it's a macro lens.
Mm-hmm.
So my microscope is a stereo microscope.
Oh yeah.
Um, Goes up to about 5 times magnification because you don't want anything too high on the magnification level. Otherwise, you can't really see what you're actually doing under it.
Yeah, you can't get the whole
Five
thing in the.
Yeah, 5 times lets you look down to um, I think about the size of like a postage stamp in the field of view. So like when you're all zoomed in, that's kind of what you see. Otherwise, you zoom out and you're looking more at like, I don't know, an A5 kind of A5, A4
Mm.
kind of scale. Um, so like it's very useful. You can basically be working under it all day at different magnification levels. Now, but that only looks straight down, so I can't really get photos on an angle
Mm-hmm.
like you see here.
Yeah, this
So to
is.
do those, I use my it's called a super macro lens,
Mm-hmm.
but it also goes up to 5 times magnification. Um, and then that
So,
just plugs into my DSLR, and then I use an off-camera flash to try to fill as much light as I can into the scene that's only about 2 centimeters away from the front of the camera lens.
and like it might be this tiny. Ridiculous.
Yeah,
Okay.
that's one of the voltage regulators on the orange crab board.
Oh. Ooh, speaking of which, one thing I'm curious about is that the orange crab, we'll do a full overview of it in a second, I think, but it appears to use the same ECP5 as the butter stick, or at least it's a very similar, it's from the same family, but it's in
Yeah,
a feather form factor. Can you tell us a little bit more about how they're similar and different?
yeah, yeah, sure. So this is the orange crab board, which I designed before the butter stick.
Ooh.
So I just wanted a way to break out the lattice ECP5 FPGA that's on this I mean, in a usable format. I mean, I don't know if a feather format's really the right board size for an FPGA, given that you don't really have access to a lot of the high-speed interfaces when you're working with just standard header pins like this.
Hmm.
But the idea is that you can put a RISC-V soft CPU on the FPGA and then essentially just treat it like a standard microcontroller at that point. But we've got DDR3 memory attached to it as well. So this was the first board I ever designed with DDR3 memory.
Ah.
And so I think I made a couple of mistakes with the routing, but we managed to kind of fix it in software, which is nice. And then with some open source, I like calling it gateware, but it's basically the Verilog or RTL code that runs on the FPGA. There's an open source toolchain called Litex that lets you design and connect system on chips quite easily.
Mm-hmm.
So it has a selection of CPUs that you can kind of just pick and choose from.
Ha! Cool.
Many are RISC-V, but there's a few other types. You can add people can add their own as well. And then it also has configuration for the DDR3 memory. And you can kind of just drop in modules like, you need an extra SPI controller. Well, it's an FPGA. You can just kind of create another SPI controller that's attached to your memory map. So it's really interesting for experiments like that, which is kind of the main purpose I see for the Orange Crab.
And it has multiple types of memory as well, right? That's one of the things that in our previous article we pulled out. I think this was a Tom Fleet article. Yeah, from back in the day. You do have, as you mentioned, a gigabyte of DDR3 memory, and then you've also got 128 megabits of QSPI flash and a micro SD card slot as well. So you can really sort of juggle memory however you like on this thing.
Yeah. And then as we were talking about before, the butter stick, it is the same chip that's on board.
Mm-hmm.
So this is also a Lattice ECP5 FPGA. But it's in a slightly larger package, so it gives us a couple more I/O pins, which lets us fire up the DDR3 memory in a dual rank configuration. So we have kind of double the memory, and gives us more I/O pins to kind of use for expansion.
That's super cool. And it looks like the new version of the butter stick also has some extra mounting holes on there. It looks like that was for working with that other shield that you had on there, maybe. And you have a new version of the Orange Crab as well. So on the blog post that I pulled up, and which is going to be linked in the description, we have this version with micro USB and also these more regular style holes in there, whereas you have these castellated edges on the new version. Are there other revisions that you've made to the newer version of the Orange Crab?
I mean, so this is the
Oh, there we
original
go.
version, and then the new one. The main differences are just to do with some of the manufacturing. So if you remember, one of those Instagram pictures you had up before was actually some of these voltage regulators that are in a WLCSP package, so wafer level chip scale package. So basically, they're silver like that because you're actually seeing the back of the silicon die. And they can be a little bit fragile. We had one owner of their Orange Crab, it stopped working, or it wasn't working when they received it. And it was because one of the corners of this chip had actually chipped.
Oh, yeah.
So there was like a crack through the silicon die itself.
I've seen those do that.
Which had basically broken everything. So we changed that to a different regulator on the new version, just so it's not even a concern for reliability now. And there was also that bit of a controversy with one of the Raspberry Pi boards. I think the Wi-Fi chipset used one of these style chips, and if you hit it with a camera flash,
oh yeah,
Wi-Fi
I remember
would
that.
restart. Because a lot of these chips are a little bit photosensitive, but
I remember that being an issue. And so Typically, I'll see these castellated edges on boards that are meant to be able to be flat mounted onto another PCB so that you can solder onto the sides of them. But in this case, I know that you have the micro SD card slot on the bottom. So I'm curious what benefit you get from the castellated edges when you have stuff on the bottom and you can't just mount it directly to another PCB.
Yeah, I mean that is true. You can mount it to another PCB, but you would have to put a cutout on the circuit board
Oh, right.
so
Yeah,
that
of
these
course.
parts could fall through, kind of through the board. Um, Personally, I just kind of like the look of it a little bit more.
They are cool.
I like seeing the edges like that. But the other application that I've not seen anybody do with the orange crab specifically, but just castellated edges in general, is if you wanted to do something with uh, like clothing and conductive threads, you can kind of tie it through the the through hole and kind of tie a knot around the castellated edge, and that provides a decent electrical connection. Now, I
That's a
don't
great point.
know how useful that is with once your pitch is down to like a standard zero point 0.1 inch pitch like this on boards that tend to be used for like textile work. I think they're usually like larger pads, like the Lily pad or something from SparkFun from a while ago, which is a bit of a larger board.
Totally, but also with one like this, if you have a smaller pitch, then there's more danger of your threads kind of coming into contact with each other and shorting out. And I imagine that the little
Yeah, yeah.
detents in the castellated edge would actually kind of catch those and keep them apart. So that's kind of a great idea, actually.
Yeah, I mean, it should help a little bit, but as I said, I've not seen anybody do that.
Mm.
One application for an FPGA in that space could actually be for driving lots of LED chains, but even standard microcontrollers these days are pretty good at that. So I'm not really sure if there's much of a benefit to going the route with the full FPGA, especially for something battery powered. If microcontroller is going to be a bit more battery friendly.
Right. And now, in terms of the orange crab, this was kind of a new format of releasing it as well. You went through the Hackster Launch program, right, which is a collaboration between GroupGets and Hackster. And I'm curious what your experience was like with that. I hear that you mostly interfaced with the GroupGets side of it. And how did that go? How did it start? And what was it like?
Yeah. So I mean, I had designed this board and was kind of showing it off on Twitter. And then the folks at GroupGets were like, "Hey, we can help make this like a um, crowdfunding campaign to make a production run of them." And then when I was over in the US for SuperCon in 2019, now it's been a while. I actually met up with GroupGets, and yeah, they turns out they can do some of the manufacturing as well. So they basically, I basically sent them the production files for the board, um, helped run some of the promotional stuff on the campaign, but then they basically took the production side on their end and fulfillment, shipping, kind of took that all out of my hands, which is good because then that's kind of stuff that I don't really want to like. I'd rather be designing new things rather than spending time, packing up circuit boards, testing them, shipping them out. So no, it was actually really good that they kind of handled all of that. And then I think it was the Orange Crab was the first board or the first project that went through Hackster Launch.
Yeah, I think you were kind of the one that launched the whole idea,
Mm.
as far as I hear from our end.
So as you mentioned, I've really just been working with GroupGets directly. But I think having it on Hackster Launch probably gets it to reach a wider audience.
Yeah, that's what the Hackster side of it is. That basically we're leveraging our audience, and so once it is released, we did, for example, this these blog posts and an unboxing video. I actually still have my orange crab. It was really exciting
Okay.
for me to to get to see this as well and be part of the project. So yeah, like blog posts and things and social media posts where we got like 1 million followers or so across different channels. And it's really on the sort of
Hmm.
promotional end. And then I think also as part of the Avnet part of it, it ends up being distributed on Farnell as well through Newark. And so sort of a distribution side and a promotional side. You also have it on One Bit Squared, which is our friend Piotr's website and company.
Yeah, so I mean, he runs this website, and he has both a US presence and a presence in Germany. Um, and he also sells open source FPGA development boards, like the Icebreaker.
Mm-hmm.
So just blanking on the name there. Still early morning for me here.
Oh yeah.
Um, so it just seemed like a good fit for him to be a reseller of that. So he was on board pretty much straight away after the GroupGets campaign. He bought up a couple and had them in his store for distributing to folks around the world.
And you folks have done some similar projects in the past with these high-speed FPGA-based LED art pieces. So which one of these are yours and which ones of these are Piotr?
So the two smaller ones are mine.
They're so cool.
So he built the larger LED panel cube,
I remember seeing
which
that
is
one at SuperCon too. I think all your of yours were there in
yeah. I mean, this
2019.
photo was taken at SuperCon,
Oh yeah.
so yeah, we're all there one piece. So that I have that on my bench here as well, actually.
Oh cool.
Um,
You have this beautiful video.
yeah, so that's this is the D20, which I designed. So it was inspired by uh, the LED panel cube that you just showed, the larger one there. But the problem is that those were designed around commercial off-the-shelf panels that are used for LED LED like walls. So like for advertising or display purposes, you can basically buy these large LED panels, 64 by 64 pixels, and they have all the
Mm.
drivers on board. You just kind of plug in a cable and you can send it data. So to make this, I had to design my own circuit boards, which used a similar driver arrangement on the back here.
Mm.
But I had to populate these with LEDs myself. I probably didn't have to, but I chose to. I didn't, rather than using a contract manufacturer to get them built for a prototype. I just decided to stay up a few nights one week and solder 2,500 LEDs.
Oh my gosh. Was it so you probably used like solder mask or yeah, solder
Yeah,
stencil and
so
solder paste and then tweezers?
stencil and solder paste, and then
Yeah.
actually a vacuum pickup tool to pick up the LEDs and place them,
Oh, that makes sense. I get them
which worked
sticking
quite
to my
well.
tweezers a lot. Wow. That oh
Yeah, and this I haven't done much on the terms of hardware since SuperCon, but I did add the accelerometer in there.
oh
So
so incredible. I also
it
love
it
how
basically adjusts the speed of the animation depending on.
wow. Does it change the color at all, or is that more dependent on other things?
So this pattern, the color changes automatically
Ah.
as it progresses. So the accelerometer here is only changing the speed, but I mean, I can work out work in the accelerometer to change other factors and make different animations and patterns and whatnot. Um, but I would actually like to update the controller board in here
Mm.
to add something like Bluetooth or Wi-Fi. I think it would make it a lot easier because right now you've got to open it up and push this little button to change the modes.
Honestly, I think that
Whereas
makes
if
it look even more magical. It's like often when you see the inside of an electronic project, it's just like this huge mess and like these horrible 3D prints and stuff. But it looks just as polished on the inside as it does on the outside. This looks like a product. So do you have are these like a little 3D printed frame and then a PCB control board holding the button and things inside? What's going on here? It looks way too
Yeah,
polished.
yeah. So it takes these batteries that are actually for my mirrorless camera.
Yeah.
Um, so you know, batteries are always a bit of a concern when you're designing something. I wanted to be able to travel with this, so I didn't want to have to use like lithium cells, like lithium
Ah,
polymer kind of pouch cells, because sometimes airport security can be a bit funny about those.
right.
Whereas if you're traveling with a battery like this, they don't like it's kind of commercial off the shelf stuff. They don't really
That's a good
bat an eye at
hack.
all. And I managed to find you can see the little connector in there at the
Mm-hmm.
base that interfaces with the connector on the battery because that's another thing. It's even if you get the batteries, it's like how do you plug in the battery to your circuit board? And so it turned out that Mauser has a TE part that is the spade connector. And then that's just on this like red circuit board that you can see, which has
Oh
the
yeah.
controller, the button, and then a lot of flex cables out one side. And then it's basically 4 chains of 5 panels each. So because it's a D20, it's 20 sided. It's icosahedron
Right.
solid. So there's 20 of these boards, and they're arranged in chains of 4 chains of 5 panels,
Ah.
and then all of that fits into this 3D print. So this is the print without any circuit boards. Uh, the one that I just had that's got the circuit boards in it was done by Shapeways.
Uh-huh.
And this one I had made with PCBWay's new 3D printing service.
And is this one
The
so the other one
tolerances are a little bit different. This one you kind of got push the lid on. Um,
yeah, where the other
I
one
don't know
had
if they
hinges.
printed it in a different orientation or not. Well, so the design is set up so you can populate magnets in these little
Mm-hmm.
pockets, and then the lid is supposed to just be stuck on with the magnet,
Mm-hmm.
um, and then
Oh,
come
it
back
almost
out.
looked like the other one had hinges on it, but I guess just rotating it.
Or no hinges. It's just there's also a cable, and actually when there's panels here, it's a little bit hard to tell which side
Yeah.
can come off. Got to look around for the little seam here. So it doesn't
Oh,
have
I
a
see.
hinge, but it does have this cable. So every time I open it, I kind of just hold it like that, so we're not ripping this
Makes sense.
fragile cable out. You've got to get data from the main circuit board up to these top panels somehow. So
Right. Wow. This is such
yeah.
incredibly advanced, beautiful work. Where did you end up getting your skills? Are you professionally trained? Did you study this? Did you pick up the skills yourself somehow?
So I have studied engineering at university. Um, so I've got a bachelor in electronics engineering and in computer science. But to be honest, we didn't do anything like this at university. Um, but I've been interested in electronics ever since I can remember. Like as soon as I started to crawl around, I was disassembling electronic products that
I
would
had the
normally
same thing.
be, recycling. So I took apart a lot of VCRs. Um, Used to pick those up really cheap at the school fair. They'd be selling off old junk, and I'd get there, and $20 gets you a lot of VCRs when everybody's moved on to DVD players. And just taking them apart and you know seeing all these components inside, not really knowing how any of it worked, but you kind of take these off the shelf parts and you create something that can display a video stream from a piece of magnetic tape. It seemed pretty kind of magical to me.
Totally magical.
So I kind of wanted to learn how to do that for myself. And so I've been kind of doing hobby electronics ever since then. Kind of started with some some of the pickaxe microcontrollers,
Mm-hmm.
which is actually a framework built on top of pick chips, and the framework basically gave you a basic compiler, so you can program the whole thing in BASIC, and then it's transferred to the chip over a serial link, and then kind of interpreted on the chip, which was a pretty easy way to start. I found that a good lead in. Uh, this was also before a lot of online tutorials,
Mm-hmm.
but the the chips were quite popular in some of our electronics magazines over here. So, like every issue of the Silicon Chip magazine here in Australia, um, basically had projects that were using this pickaxe chip. So, you'd look through the projects and get inspiration about other things that you could do. Um,
That's awesome.
support, build projects verbatim out of that.
So
Um,
was the Orange Crab your first production run electronics product?
um, yeah, I think it was. I, I've been kind of designing a lot of stuff, and I've sold things at smaller scale on sites like Tindy before. But no, the Orange Crab stuff is the first product that I've designed that's we've used a contract manufacturer, and now it's available through distributors.
Wow, yeah. So what was that like going through a contract manufacturer for the first time? Did you get any help with that process through GroupGets, or was that more you did that on your own and then you came to the program and or helped create the program, I guess. Did they like help you through it in any way?
It's actually funny because it was kind of all out of my hands. It's GroupGets already had people in place that they've used for that stuff before. So I think the orange crabs are actually manufactured in a facility in Reno, in Nevada, um, basically just down the road from GroupGets. Um, and so they pretty much handle all of that, and I didn't really have to lift a finger. So
So things like deciding on choosing a manufacturer, choosing components, had you already sort of selected the components that you wanted to use, or did they sort of reconfigure all of that as well in terms of the designing for manufacture?
so I'd already built the prototypes myself.
Right.
And more or less, the prototype was in a state where we could just produce that at scale.
Hmm.
Um, and that's what we moved forward with in the campaign. I mean, you could spend a bit more time on the design front to get it a little bit, maybe a bit cheaper, maybe a bit easier to manufacture. Um, but from my perspective, I would rather just have had the boards and the chips out into people's hands that wanted them.
Mm,
Especially when I designed this, there weren't many other ECP5 based boards. And the ECP5 is interesting because it's quite a capable FPGA that's also supported by the new fully open source toolchain,
mm,
um, which is a combination of a couple of software tools. But it means you don't have to use a tool like Xilinx's ISE or Vivado or some of these larger
right.
IDE tools that sometimes have quite restrictive licenses. Even if they're free, you've still got to sign up a license and register your computer to use the software. And it, that might not seem like a big deal to many people, but honestly, the open source toolchain is kind of it's interesting because it opens up a lot more possibilities and avenues for um, just like interesting projects. So
Mm,
one here is the where have I put it? My desk is up. Here it is.
And is this the icebreaker
So,
toolchain you're talking about?
it's used by the icebreaker.
Oh,
So the icebreaker is an ICE 40 based chip, which is also from
oh,
Lattice.
right.
Um, but it is a little bit more lower power, less capable chip. The ECB5 can run faster and has more resources
I see.
inside. So this board here is the Glasgow board, which
Haha,
is kind
wow.
of like a USB to yeah. Let's get some nice little circuit board artwork there. It's more or less a USB to like I/O to interface kind of board, quite similar to something like a bus pirate. I guess you could say like a high level. But this has an FPGA on board, and the entire software stack kind of makes use of that fact from the beginning. So you can tell this to transmit UART packets over some of the pins, and the software will create a UART module, instantiate that in the FPGA, load it onto the FPGA, and then drop you into a terminal that's showing you the UART data coming
Ah,
through.
so you're just talking to it over serial at that point.
Yeah, so
Mhm.
it's like all like transparent to the user that this is all happening behind the scenes, but the whole software, so the hardware for this and the software is all open source, and that's really only enabled because of this open source toolchain, because the toolchain is included in the software package for the tool, which I don't think you'd be able to do with any other FPGA because the licensing agreements wouldn't let you redistribute, um, the compiler in that manner. So it's really interesting. So that's just one example of how, more or less, it's similar to microcontrollers,
Mm-hmm.
where a lot of companies would have their own compiler for microcontrollers, but then GCC came along, and GCC can basically program more or less like pretty much most microcontrollers on the market now, and that just kind of makes things more like streamlined, progresses like everything forward, because any optimization in GCC currently, um, might improve performance of every program that you compile from
Yeah.
then on out. So it just makes more sense to lump all resources into one tool like that. And I think that's what we're seeing with the FPGA movement now with some of these open source stuff. There's support for a couple of other chips now that has come into the tool chain, um, like the Quick Logic FPGAs. They're now supported, and then there's support is still in the works for some of the Xilinx. Is it Z A7? Arctic 7, the
Oh, yeah.
Arctic line. So I think that's to a point where you can put a softcore processor on the FPGA and have it running, but there's still a couple of um, quite a lot of missing blocks that haven't been
Mm.
added in yet. Um, but no, it's all very interesting stuff. Um,
So, let me ask you another question about the business and manufacturing side of things. How have you settled on the pricing for this? Is this something that you determined, or what are the factors that go into determining that for you?
I think the price is basically set based off um, the bill of materials price,
Mm-hmm.
the contract manufacturing, and then margins for. Uh, there's a margin in there for GroupGets and a margin in for the distributor,
Mm-hmm.
and then I get a little bit of a kickback on the end for doing the design. Um, But that is one disadvantage of shipping products through distributors is they do often want like a reasonably high margin,
Right.
um, which for this is quite a kind of a niche product. So I feel like the price isn't too much of a deterrent if you look at other FPGA boards that are on the market. Um,
Especially the ones from big companies can run easily into the hundreds of dollars, like multiple hundreds.
yeah, yeah. And my other counter to that is I'm also releasing all the files and designs as open source. So
Right.
if you if people do think that the cost is prohibitive in a sense that they could make it for cheaper, I would, you know, I'm not opposed to that. You know, people have made runs of orange crabs to sell on their own, or more often they've taken the design and then adapted it a little bit for their own device or use case, which I also encourage.
And you do have the sixth OSHWA certified hardware project from Australia, which I love. I love that you can look them up like that. I noticed that you had the AU006 ID on there, and you can find that it is, yeah, number 6 on here after Tomu being the first one, which is super cool. How does that certification happen? Is that something you did independently, or that happened through the launch process? Or yeah, how does that happen?
Yeah, yeah. No, you have to apply independently. So usually it's the project creator has to apply it, I think. Um, and it's a little bit restrictive. I wanted to do it for the butter stick, but they treat they basically would treat the butter stick, uh, the two versions of the butter stick that I showed earlier, as different products. So they would have
Oh.
different IDs because they're quite like they're distinctly different in the sense that like one schematic doesn't line up to one board and stuff like that. So I do need to get around to lodging an application for the new Butterstick board, and then I could probably get what's on that list, number 9 or number 10.
Something like
There's
that.
uh, not many Australian products that have pushed through the uh, the open source hardware
Yeah, you might get number
certification.
10 here.
Um, but no, I mean it's it. I don't really know what it does in terms of marketing or whatnot, but it kind of just shows that at a glance that the product is open source in the sense that you've got the board designs, you've got the bill of materials, you've got like source code to run on the product, like enough to
Yeah.
reproduce it. Because I think you can put the open source hardware logo on your board as long as you're releasing one aspect of the product. So you could still put that logo on even if you're only releasing schematics, even
And
if
no
schematics
software or
aren't
firmware or
really
anything.
enough to reproduce in its entirety the product that you're selling.
Right.
So the open source um, certification and the little logo that like the ID number you get, and then adding that logo kind of is just a way to signify that there's enough information as part of the open sourceness of the product
Uh-huh.
or device or idea so that you can fully reproduce it.
Ah. And how long does that take typically for the process? I mean, I see that you've gone through it once, obviously, and you've worked on getting through it a second time, but yeah.
I think it. I think it has to be manually reviewed before they assign you a number.
Mm,
But all the form, like the form to fill out, is all online. I think they typically do want you to have, or it's easier to do if you've already got the product finished.
right.
Um, but I have also seen a few circuit boards that have put the logo on the circuit board itself. So I think it is possible to get a number before you've actually finished
Right, because otherwise it'd be
manufacturing.
kind of a catch
Um,
22, wouldn't it? Like you You have to get the
But
number to make the board and the
yeah, I don't know. I think it's a little bit more tricky because you basically have to show that all the designs are finished and available online, and documentation and possibly some of the firmware before they'll give you a number. But
mm.
you've got to do all of that without building a prototype or without building that prototype,
Yeah, yeah, yeah.
So, I mean, I guess you could do it for the butter stick here. We could get the number and then on the next circuit board revision, just put the number on the circuit board at that point. But yeah.
It's interesting to me that they have a term here of if you do not agree with any of the above terms, please explain. It's like very unusual to me, it feels like in a sort of certification landscape. It's so interesting.
Well, I think it's still a relatively new scheme, so I think they kind of do want feedback if there's some I don't know clarification needed, or if they can explain a bit more about how they think the open source initiative would help your product or something like that. Like some people might be misinterpreting exactly what open source means, and they think if
Mm.
they open source their product, they're not going to get any not going to get any revenue, or people in China will suddenly clone the product and undercut you or something like that. Um, the reality is that happens regardless of any of this anyway. So
Fair. So yeah, looking into the future, you've got Butterstick coming up through the process next. Very exciting. And we've got some information on that out already. Is there anything going differently with that experience this time around?
well, the only difference this time around, I think, is the fact that we're in a bit of a silicon shortage. So
Yes.
it's been a while actually. The butter stick, we finished our campaign for it um, in February, I want to say, and we placed the order. So in order to get the pricing for the campaign, we basically have to buy a lot of the parts directly from manufacturers
Right.
in like trays or reels. So at the end of February, we um, got all the totals from the campaign. We placed an order with Lattice to make the FPGAs, and what used to be an 8-week delay, they said would be closer to 36 weeks.
Oof.
So I think the current estimate is that the our FPGAs will probably be delivered to our manufacturer in mid-September. But I need to follow up to see if that's still accurate. There's some other parts, like some of the regulators on here are a Texas Instruments part, and we ordered those in February with an estimated lead time of September. So we're already waiting on the FPGAs, so we thought that's fine.
Mm.
We'll place the order and go ahead. And then Texas Instruments seem to be pretty hard hit with a lot of their parts now, and they what they quoted for in September is looking more like March next year.
Oof.
So we'll, I guess we'll just kind of get through it. But from my end, I'm just kind of waiting for these parts to show up.
Yeah, is there anything you can do
But
in terms of like workarounds? You can't replace them with other parts. I imagine that the same parts, even if equivalents exist, they're probably equally delayed. Or is there anything you can do to mitigate that?
yeah, so it's a little bit tricky. I mean, we could have done some things a bit sooner to mitigate. Um, but as I say, we were waiting on the FPGAs. So
Right.
I guess we kind of had the thinking that if we've got to wait till September on the FPGAs, we might as well just, wait for all the parts. Um, naively thinking that they'd all
Ugh.
be on track to deliver when they when they say they are. But I guess when your lead time ends up being over 12 months away, it's a little bit hard to schedule production, on the manufacturing of chips side, 12 months in advance, perfectly accurately. All it takes is, you know, one one blackout or something, and you're pushed back a couple of weeks um, with manufacturing of the chips and stuff like this. So if we thought this would have been a problem in February, we probably could have at that point gone back and redesigned to get rid of some of these other parts, um, go through the entire bill of materials and try to find parts that we can source from multiple vendors that
Mm-hmm.
have like multiple drop-in replacements. But at this point, feels like if we did that now, we'd I don't know.
And you'd
We
have to
might
go
have a bit
through
of a
manufacturing again. You might have to have like different footprints and things. I don't know. That also seems
yeah.
complex.
I mean, at this point, we have already ordered the circuit boards. Like the circuit boards are already sitting with our contract manufacturer, and half the parts are as well. So at this point, to redesign it, it kind of feels like two steps backwards. Um,
Absolutely.
Maybe that's a bit of the sunk cost fallacy, but because it could be we get to March and TI says, "I know the parts will be here in July," and then in July it'll be, "Oh no, September."
But also,
It's
you don't know what would happen if you tried
you
and
don't know.
switched out with something else. Like the other thing might also experience the same delays. I don't think it's
Yeah, yeah, exactly. I mean, or we could buy the parts now, and when we have the parts, redo the design. But then that only fixes this production run. The next time we run these boards, we'll just hit the same issue again. So
yeah. Plus, would you
um,
have to recertify?
on the open source hardware certification, you mean?
Mm-hmm.
I think if the product is functionally identical, I think it's okay.
Mm.
Um, they have a bit of a technical wording of like a non-major change, and so as I was
Ah.
talking before, I think just the fact that we've changed like the type of RAM that's running on these chips, like these boards can't really run the same software at this point. So yeah, in my eyes, it definitely, I understand why they would have these two as different,
That makes sense.
um, needing different certification. But I think if you just change parts in order to improve manufacturing, or improve lead times of parts or something like that, I don't think that would be a problem.
Mm. Awesome. Oh, thank you so much for sharing these with us. I'd like to give people again a quick tour of your beautiful work. Let me pull this up just a second. We've got your Instagram with there's so many things here that actually I'd love to talk about. Like this, I feel like part of the reason that Oshpark introduced their After Dark colorway is because of this getting tired of hiding all this beautiful circuitry under opaque solder mask. And
Yeah,
this it's just so lush. There's so much beautiful photography, not just of electronics, but of cool moon phases and things like that. So people can follow you on Instagram and Twitter. If people want to do their own launch, you can go to groupgets.com/launch. You can find Fireflight at fire.aero. You have a website, but as with many of us, it is not the best place to stay up with all the current stuff going on for you. You've
yeah.
got
I just find it a lot easier to just you could post a quick picture on Instagram or Twitter rather than sit down and write up a full blog post.
totally.
Um,
You can find Orange Crab on GroupGets and get them on Farnell eventually. We do have the same backorder issue going on, or 1 bit squared if you're in Europe. Seems to be an advantage. You can figure out how to get OSHWA certified at OSHWA.org. I have one final question for you, Greg. Also,
mhm.
anything that you'd like to throw in there before we wrap up here. Now is maybe the time for that. But then I'll ask you one question.
No, I think we've probably covered enough.
Okay, final question. How do you name your boards? You have the orange crab, you have the butter stick, you have Arctic koala. What's going on here?
So I I did struggle with naming products for naming projects for quite a while. Um, so I eventually found a website that I think it's just codenamegenerator.com or project codename,
Ha ha
I
ha ha.
think. Um, More or less, it just picks kind of funny combinations of words. So that's why you get things like the orange crab or the butter stick. Or I think butter stick. I think I just came up with that one because it kind of looked about the same size as a stick of butter. But the Arctic
Ah,
koala is another one. So you just kind of push the button, and it'll create a code name for you. I was
right.
using these as internal code names for projects, and then I figured, why not just release them under that name instead of trying to make a new name and confuse everybody with like an internal code name, but I'm sharing things publicly, so it's not really internal. And then if you release it under a different name, it's
Right, because we
you know,
probably all your stuff on GitHub or whatever is gonna have that original name. So
yeah. I GitHub, I think you can rename repos, but then yeah, any links still have the old name, and then
anyone who's
it
been
does
following it.
redirections correctly, but yeah, eventually that might not work. So
Mm,
it is useful to stick with a name initially and then see it all the way through. So that's what I've been doing. So
I like
yeah,
it.
as you
So
mentioned, Arctic koala, yeah, butterstick orange crab, the obsidian boa. This is another
oh,
board.
that's a good one. What is
The
the obsidian boa?
It's just a small run of boards I did with the ESP32.
Hmm,
Um,
I'll check that out.
so I've got a few left here, but so it's like a fairly small board here. So it's the ESP32 S2. So Wi-Fi, Bluetooth enabled with internal USB. So have the USB port there, and then we've got flash and SPI PS RAM attached as well. Nice
Hmm,
little cute little Wi-Fi antenna on there.
that's very cute.
This is a board that fits the Ice Bitsy format,
Mm-hmm.
which is a little format that was designed by um, Peter over at One Bit Squared again.
Mm-hmm.
So this is an early version of the Icebreaker Bitsy, which is more or less the same kind of footprint there. This one's got some extra pins for programming on the end, but
Uh-huh.
there's a new version that actually is the same, matches the footprint the same. And I believe um, when the folks at One Bit Squared get enough time, they might be releasing something like this with the ESP on board. I kind of told them that they can take the design. So I did the prototype for this, but I don't really have time to work on all the other aspects that come with releasing a product, like documentation and example code, example projects. So I kind of let them take the lead on that, but they've got some other projects that are already in their pipeline ahead of it. So at some point, yeah, you might be able to buy these directly, but I did sell a couple on my Tindy store. Um,
Yeah, I have a
so
question about that actually.
there's a few out in the wild.
Yeah, so this is released under Good Stuff Department. Is your middle name Steven or something? Because GSD, it looks like Gregory Davill with something in the middle.
Yeah, no, it's Scott.
Ah!
So yeah, no, I'd already put my initials on a lot of circuit boards. Um, see, this is another one. So I have my initials on the circuit boards here, GSD.
Aha!
And so when obviously I'm sharing a lot of my work, so I get inquiries about doing consulting projects quite a lot. So I basically spun up a little consulting company for that. And instead of trying to pick up a new name and a new logo, I just kind of stuck with the GSD as a logo, and they had to find what's the term, a backronym. When you go from something like GSD, you try to work out the words that could make that up, and then try to work out if it's available as a domain name and not registered currently as a business in Australia and all that other fun stuff. So that's how I ended up with Good Stuff Department, because it
Brilliant.
turns out nobody else makes good stuff, I guess. Or I don't know, they haven't thought of thought of using that name, but it's been interesting. There's not too many mix-ups between the two, but basically all the stuff that I sell through Tindy, it's kind of under the brand name Good Stuff Department. It's very like vague and like ominous because it doesn't really describe anything that I'm doing. But
well, it gives you lots of flexibility.
yeah, exactly. You can do anything with that name, I guess.
I appreciate that you've also got this kind of diagonal knolling thing constantly going on, where you're clearly like a photographer. You clearly have an aesthetic where everything must be lined up. Oh man, a little 45-degree angle.
Well,
yeah, it's very good.
I think it just looks a bit better, I guess.
It does. Well, thank you so much for joining us. Such a pleasure to have you on the show and ask you about these things. I've seen this close up, and I've had so many questions as it's been evolving, and now we get to sort of see what comes next for you. Everyone's got to follow you in the links below. Yeah, thanks again.
Yep. Thanks, Alex, for having me.
Rock on, Greg.